All right, this video is going over Unit 6, Lesson 2 on analyzing data and making predictions using the line of best fit. Okay. In the last lesson, we saw how the association relationship between two variables can be displayed on a scatter plot and how lines or curves can be drawn through the data. Today, we will look closer at the lines of best fit and their equations in y equals mx plus b form and what they tell us. Okay, so this is a graph from yesterday about how many hours you spent studying and the impact it has on your final exam score. The line of best fit is written as y equals 4.6x plus 52. So what is the y-intercept? Well, y equals mx plus b, so our y-intercept is 52, which would be the point 052. So what that means is our x-coordinate is 0, so 0 hours studying gives us a y value of 52 for your final exam score. So what we can write is that if you study 0 hours, this prediction line says that you'll get a 52. That might not actually happen, but that's what the trend shows. So let's see. Someone who studies 0 hours will earn a 52% on their final according to the prediction line. Okay, what is the meaning of the slope? Well, our slope is our m, so our slope is our 4.6. Now we can write slope as change in y over change in x. So we have 4.6, and when there's no denominator, we can make it a fraction by writing it over 1. Okay, so let's look at our y is their score. So we could say like 4.6 points. Whereas our x-axis is hours, so it will be points over hours. So what this means is your score tends to increase, right? Our prediction line is increasing, our slope is positive, 4.6 points per hour spent studying. Okay, so the line estimates that for every hour you spend studying, your score will go up about 4.6 points. That's our rate of change, our slope. Okay, use the equation to predict the final exam score for a student who studied for 3 hours. So I'm going to rewrite our equation, y equals 4.6x plus 52. And let's plug in 3 hours. So hours is the x-axis, so I'm going to plug in 3 for x. And if you put this entire thing in your calculator, you will get a 65.8, which rounds to a 66% final score if you're studying for 3 hours. But what happened when a student actually studied for 3 hours? So if you look at our graph, a student that studied for 3 hours scored a 60. So does the actual score, the 60, match the predicted score? No. The actual score of a 60 does not match the predicted score of a 66. So why? Well, this happens because the points don't perfectly line up with that line of best fit. So it's a prediction. It's close, but it's not going to be completely accurate. So you could say this happens because the data points don't fall exactly on that line. They don't fall perfectly. They don't fall perfectly on our line. It's just a line of best fit. All right, use this equation to predict the final exam score of a student who studied for 12 hours. So let's rewrite our equation of a line for our line of best fit again. And x is the number of hours, right? We got that because on the x-axis, it shows the hours. So let's plug in 12 and see what happens. So when you put all that into your calculator, you're going to get 107.2. Is this realistic? It's not realistic because on a final exam, it's going to max out at 100 unless there's bonuses. But you can't just keep studying saying you study for 13 hours, 14 hours, 15 hours, and your score's just going to go up, 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 up. Eventually, it's going to just kind of like plateau, and you'll no matter how much you study, whether it's 30 hours or like 500 hours, you're going to just get 100. So this is not realistic. If the highest possible grade is 100. Okay. All right, so looking at our second one, the line of best fit that they give us is y equals negative 0.08 x plus 12.25. So our y-intercept is this 12.25. So that would be the point 0, comma 12.25. 0 is our x, our number of years. And this is your number of hours of sleep. So when you're 0 years old, you're getting 12.25 hours of sleep. So we can say a newborn is predicted to sleep 12.25 hours per night. The slope is negative 0.08. We can write that over 1. 0.08 would be our, remember, slope is change in y over change in x. So our y is the number of hours, and our x is per years. So you can say the amount of sleep you get decreases because of that negative by 0.08 hours per year. This is for every 1 year. So that's our slope. And now let's predict how many hours of sleep a 13-year-old can get. So let's rewrite our equation, which was y equals negative 0.08x plus 12.25. The age is the x-axis, x for the age. So the 13 years will plug in for x. So you can type all of this into your calculator to figure out the prediction of the amount of sleep a 13-year-old would get, and you're going to get 11.21 hours, which again is just a prediction, and you can look at your graph to see a 13-year-old would be somewhere around here, and our prediction line is saying that it would be about 11 hours of sleep. Again, just what the trend tends to be based on the data. Okay, fishing. So 200 trout are caught, and they have data saying how long the trout was compared to how much the trout weighed. So the y-intercept, well, we have y equals mx plus b. So our b is 1.5. So our x is 0, which is the length of the trout, and our y is 1.5, which is the weight of the trout. So what this is saying is that a rainbow trout that is 0 inches long, right? 0 inches in length is predicted based on this trend line to weigh 1.5 ounces. Is this realistic? Does this make sense? No. If it is 0 inches long, that means it really doesn't exist. There's nothing there to measure. It's going to weigh 0 ounces. Not 1.5 ounces. So this is just an example where we're showing you it's a prediction line. It's an estimate. It's not going to be perfect, but the trend based on the data shows that you would have 1.5 ounces when you have 0 inches, even though we know that that's not going to be true. The slope is 7.3. That's the m in our equation. Change in y over change in x. So our change in y is 7.3, and our change in x is 1, because you could just write it as a fraction over 1. And let's do our units. Our 7.3, that's going to be our y, which is our ounces, over our x, which is our inches. So that tells us that the fish is increasing 7.3 ounces for every inch that it increases. The weight of a trout tends to increase by 7.3 ounces per each 1 inch. Okay, Jesse catches a rainbow trout that is 2 feet long. Use the equation of a line to predict how many ounces. Y equals 7.3x plus 1.5 is our equation. And now we have 2 feet. We're going to have to convert that to inches. So that would be 24 inches, because there's 12 inches in a foot, because our graph is looking at inches. So now if you go to 24 inches, you can estimate based on this how many ounces the fish is supposed to weigh if it's about 24 inches. So it looks like it's going to be somewhere between 150 and 200. Let's see. Plug in 24 for x, because that's the number of inches. And you're going to get 176.7 ounces, which sure enough is in between 150 and 200. Okay, for D, Deanna catches a rainbow trout that is 38 ounces. So let's rewrite our equation again. This time we're plugging in for the ounces, which again, looking at your graph, the y-axis tells you your ounces. So we're going to plug in 38 for y and solve for x. We would minus 1.5 on both sides and get 36.5 equals 7.3x. Divide by 7.3 on both sides, and you're going to get that x equals 5 inches. So a rainbow trout that's 38 ounces would be 5 inches. Okay, we have 2 more. Okay, so this one is looking at lawn services. Whoa, blurry. The number of lawns that you mow and how much money you make. Makes sense. The more lawns you mow, the more money you make. Our y-intercept. There's no equation here, but we know that the y-intercept is where our line crosses the y-axis. So the b is 0. This line goes through the origin, 0, 0. So what that means is that our x is 0, so that would be 0 is the number of lawns mowed. And our y is our income, how much you make, $0 made. That makes sense. You mow 0 lawns, you make $0. Okay. The slope. We're going to have to figure out the slope. You can do rise over run. So it looks like there's another nice point right here. So we're going up 300. And then we're going to the right 10. Because remember, one way to find slope is rise over run, change in y over change in x. Our change in y, we're going up 300. and we're going over 10. If you simplify that, you'll get 30 over 1, which is 30 is the y, so that's the number of yards over $1. So what you can say, the slope or the rate of change tells us that you're going to make, oh, I reversed that, didn't I? This is supposed to be money. Sorry, the y is money. And this is how many yards you mow. Oh my gosh, you can't even see. Okay, so again, it's change in y over change in x, so it's 300 over 10. 300 is the dollars for 10 yards that you mow. So $300 for every 10 lawns that you mow. 300 over 10 simplifies to 30, so $30 per yard. So the income tends to increase by $30 per yard that you mowed. So you do another yard, another lawn, whatever, you get another $30, that'd be 60, and so on. That's the trend. Using the line of best fit, predict how much money Nicole will make if she mows 25 yards. Okay, so this one we could just use the graph. 25 yards would be right here in between 20 and 30. The predictor line looks like it's right about here. So if this is 700, in between 700 and 800 would be $750. For mowing 25 yards. If you wanted to, you could have used the equation, which would be y equals 30x, because we said our y-intercept was 0 and our slope was 30. And then you would plug in 25 and you would get 750 that way also. All right, and using the line of best fit, predict Michael how many yards he mowed if he made $900. So let's start off by using our equation. Plug in 900 for y, that's how much money he made. And then you could solve for x by dividing both sides by 30. And you would get 30 yards. I think it's going to be easier just to use the graph. Let's find $900 on the graph and see how many yards that was that you had to mow. $900 would be right here. Lines up with our line of best fit right here at 30 yards. So Michael would have mowed 30 lawns to get $900. All right, and lastly, we have some cars, used cars. This is in thousands. So a car starts out at $11,000. So our y-intercept is 11,000. So the time since you purchased, so this would be 0 years since you purchased. The value is 11,000. So we could say that a car that is just purchased, brand new, has a value of 11,000. Okay, and then the slope. All right, so we're going to have to figure it out. So we could do rise over run. I see another nice point right here. So we're going down 1, 2, 3, and then we're running 1, 2, 3, 4. So our slope, which is our rise over run, can be written as -3 over 4. But it's important to note that this is down 3,000 over 4. And if you simplify that, you're going to get -750 over 1. Our y, right, because slope is change in y over change in x. Our y is our money. And our x is the number of years. So your car is negative, right? So our car is decreasing in value $750 per year. The value of the car tends to decrease by $750 per year. All right, and then we have to predict how much Aaron's car after 8 years is going to be worth. So let's write our equation. Y equals mx plus b. Our m we said was negative 750 over 1. And our b we said was 11,000. That was how much you started at 0 years. So now let's plug in 8 years. Years is x, the x-axis. So let's plug in 8 for x. And if you put all that in your calculator, you're going to get $5,000. So his car will be worth $5,000 after 8 years. And then lastly, rewrite your equation again. A car that has a value of $8,000, car value is y, the y-axis. So we're going to plug in 8,000 for y and solve for x. Minus 11,000 on both sides. We're going to get negative 3,000 equals negative 750x. Divide by negative 750 on both sides. And you'll get that x equals 4 years. We also could have used the graph for these. So I'm just going to show you if you go to 8,000 on the graph, 4 years. That probably would have been easier. And for this one, if you go to 8 years on the graph, you should get $5,000. 8 years on the graph, $5,000. So I would do both to check. All right, this was a tough lesson, so thanks for taking the time to watch. Bye.